The quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So a and b and c are real numbers such that a cannot equal 0. Remember to write the quadratic equation in standard form before applying the quadratic formula. Let's jump in and, well, first of all, this is quadratic form, right? Here's your quadratic equation in standard form. It means all the numbers and variables on the left and zeros on the right. Let's jump in and look at this first example. So here we have x squared plus 3x equals 2. First thing we want to do is put it in standard form. So we'll subtract 2, giving us our standard form equation. Let's identify what a, b, and c are. 1, 3, and negative 2. Let's substitute the values into the quadratic formula. And there we have it. Simplify. 3 squared is 9. 4 times 1 times negative 2 is negative 8. Negative negative is positive. The denominator is 2 times 1 is 2. And our final answer is negative 3 plus or minus the square root of 17 all over 2. And you may recognize this solution as coming from completing the square. So if we were to write this solution in a solution set, you would have it like this. I also want you to realize what kind of solutions these are. These are roots, also known as the x values. And because the number under the radical is not a perfect square, then this is an irrational solution. Okay, so that's what this 1, 2, 3, and 4 mean. Is it imaginary? No, it's not imaginary. There's no I. These are real solutions. Is it real, rational, and equal? Nope, it's not rational. Like I just said, this is irrational because it's the square root of a non-perfect square. So it's real, irrational, and unequal. Example 2. Let's put it in standard form. Subtract 12x, add 9. Here we have our standard form of our quadratic equation. Step 2, let's find a, b, and c. Well, a is 25, b is negative 30, and c is 9. We'll substitute into the quadratic formula, and there we have it. Finally, we evaluate. Negative negative 30 is positive 30. Negative 30 squared is 900. 4 times 25 is 100 times 9 is 900. 900 minus 900 will give us 0. And 2 times 25 is 50. The square root of 0 is simply 0. So we basically have 30 plus 0 and 30 minus 0, which are both 30. 30 over 50 reduces to 3/5. This is an interesting answer because there's only one root. You could also consider these as equal roots. So this is kind of a dead giveaway. The answer is that these roots are not imaginary, are not irrational, they're not unequal because they're both exactly the same answer. They are real, rational, and equal roots. Example 3. Put it in standard form, subtract 5 from both sides. A, b, and c are negative 1, 4, and negative 5. Let's substitute in. There we have it. Evaluate. And we end up with negative 4 plus or minus radical 16 minus 20. Now the 16 minus 20 is going to give us a negative number under the radical. This should give you an idea that this will be imaginary. So negative 4 plus or minus 2i over negative 2. We can further simplify this because every single term is divisible by 2. We'll divide 2 here, divide 2 here, divide 2 here. We end up with 2 plus or minus I, or 2 plus I, comma 2 minus I. So let's think about it. This solution is not a real number. It's imaginary. Final question. We have adding 24 to both sides gives us our quadratic standard form. A is 3, B is 42, C is 24. Substitute in, we end up with this. Evaluate, and we have, I went ahead and worked it out on a calculator. I wanted to get the decimal approximation. So we ended up with negative 0.597 and negative 13.403. I want you to compare this with our very first example right here. Oops, that's not it. This is it. It's the exact same problem, except we used completing the square to solve this. So as you can see, when we complete the square, we end up with this solution, negative 7 plus or minus radical 41. I also want to point out that when I put this in the calculator, I end up with negative 0.597 and negative 13.403. This should look familiar. It's the same answer, the exact same quadratic equation, two different methods to solve it. One was completing the square. This is quadratic formula, showing you that doesn't matter what tools you use, the answer is the answer. There's the lesson. Best of luck to you.